So welcome to the first of two parts relating to operational reliability. This one is going to focus on track work and the electric supporting it. The second one will be on stock. The key thing about all this stuff with reliability is, imagine that, if you make the metaphor of using your car and you go to Oxford or Birmingham, and the car, it breaks down at Southampton, it breaks down at Oxford or Newbury on a wet, rainy night. It just destroys the journey. And I've seen this many times when I've gone to model railway exhibitions and see people running trains, and the train fouls on points. The same train fouls on the points an hour later because they've never gone through that testing process. And we need to have reliability because we're using computers to run the trains on the hidden sections, which is what this is here. So the guys are going to show you a number of factors that we use, starting with electrical connectivity through to a look and feel, to points, checking that trains can run through at ridiculously high speeds, so that if that works, we know that any train that comes off in the future, it must be the train, not the track. And then we finally double check that all the digital connections are reporting to what they're doing. Once we're happy with that, we can then sign a particular level off and move on to the next stage, which is going to be really exciting because that starts to get to the operational levels. So I hope you enjoy it. Thanks.
We're now at a point where we're going to test the track continuity. The track has all been laid and the droppers from the track have all been connected through to the track and soldered on, and they all go back through to the BDL168, the track circuit board. So what we're going to do with Ian by the BDL168 is connected red 28 onto the red 28 connector there where we're expecting it. And what I'm going to do is, with my other side of the feeder, is I'm going to put it down onto the track and just make sure that we get the beep so we know we've got that connectivity. So if I press on red 28, we get the beep. If I come to the other side into the next section, which is red 27, and we've got an isolating fish plate here, this section should be totally isolated. So we test that, we've got no beep, so therefore we know that that is a good connection. We then follow all the way through in red 28 and just make sure that every dropper from red 28 is actually feeding through and is connected. When we come around the corner and we go into red 26, we find we've got no beep, which is as to be expected. So that's the test completed on that one section of track. This test is carried out on every stretch of track, basically to make sure that we have got that connectivity, because the last thing we want to do is to build the next layer up and then find that we then got track issues, which we then have to go back and retrospectively fix.
I'm checking for rough spots, solder where it shouldn't be, rough edges where it was cut, and in fact this piece is quite good, no problems at all there. But we always have to check points because they can be a problem. Black marker pen shows it up. And the file. Yes, that one's fine. I've only got another 37 to do.
We're now going to test the frog polarities. You may remember that from a previous video we mentioned about our template of the different positions of all the points and the point motors that sit underneath. What we're now going to do is we're going to test the frog polarity depend upon those configurations to make sure they're working correctly. And the way we do this is, at the moment we're going to do the test on point 308, which at the moment is set for straight on. So the first thing we do is we check the stock rail. So I place the multimeter on the stock rail and I check the blade. That gives a positive signal. I check the closure rail, positive, and then feeding all the way through into the frog. And it doesn't matter which blade of the frog, it actually still gives you the positive feed. If we add a short, we get a short circuit sound. That sounds like this. So I'm now going to get Ian to change over 0.308, so it's now set as off in the opposite direction. And this time what we're going to do is we're going to test the polarity of the frog with the point switched in the opposite direction. So this time we test the other rail. So we test the blade, and then with the closure rails, either side of the cut, all the way through into the frog, and we've got connectivity. And once again, just checking the other blade, which should give us a short, and we get the buzzer for the short. And that is the point frog continuity check. And we do this for all the points to make sure that everything has all been wired up correctly.
So the penultimate part of the testing is to hammer one of our test trains around the layout at silly speeds, at a scale of 125 miles an hour. And the whole goal of that is to just see that it stays on. It generally comes off the first 2 or 3 times you run it. And then the really important thing we have is that it allows you to prove beyond doubt that the track is reliable. And that's the only way we know to do it, through all the sidings, through all the loops, backwards and forwards, time and time again, and then finally run it all the way through. There's about 30 runs at high speed through one level, and then once we've completed and satisfied ourselves with that, we're then fairly certain that the track is in good condition.
We're now just going to do a further test to make sure that train controller is picking up the orientation setting of the points correctly. So at the moment, 0.310 is set for on because it's following to row line red 4. So Ian, if you'd like to change 0.310, please. And that should now switch over to show for line red 8.
Yep, confirmed.
And that's the test. If you'd like to switch it back, and then back to red 4. And we do this for every point and every block detection section. We've done the continuity check back to the BDL 168 train detection board. We now need to check further back to train controller to make sure that the connection between the BDL 168 is actually going all the way back into train controller. So to demonstrate this, we have a loco number 5061, which if we put into red sector 4, Ian will now check the train controller to make sure that it is being recognised and picked up. So Ian, locomotive now going into red sector 4, on track now.
Confirmed.
Confirmed. Okay, so that's that check completed, and we now know satisfactorily that that goes all the way back.